In this lecture, we will learn about the build, execution, and deployment section of the settings window. Let's open up the settings window by clicking Ctrl-Alt-S. Then we will click Build, Execution, and Deployment. This will give us an overview of the different subsections. The Build Tools option lets us configure project integrations with the Build Tools Maven, Gradle, and Gantt. The Compiler option allows us to configure settings for the different compilers used in Intellij IDEA. The Resource Patterns field lets us specify the regular expressions for files that should be recognized as resources. The Clear Output Directory on Rebuild option allows us to delete all files in the output directory when the project is rebuilt. Add runtime assertions for not null annotated methods and parameters means that all methods that are annotated with @notnull have assertions added to them at runtime. The Automatically Show First Error in Editor option allows us to automatically open the file that contains the first compiler error, and have the line highlighted that is producing the error. Display Notification on build completion makes a pop-up notification display if the build process takes longer than 1 minute. The Build Project Automatically option will rebuild the project whenever a change is made. Compile independent modules in parallel lets us compile mutual dependencies simultaneously. The Rebuild Module on Dependency Change option means that modules will be fully rebuilt when the dependencies are changed. We can specify the heap size in the Build Process Heap Size option. Shared Build Process VM options lets us specify VM options to be added to the command line on launching the build process. User Local Build Process VM options also lets us specify VM options to be added to the command line on launching the build process, but these preferences will override the shared options. Next up comes the Exclude settings. These settings specify files and folders that will be excluded from the profiler. The Path field shows the path to a file or folder that will be excluded from compilation. The Recursively option lets us exclude all of the subfolders of the directory we specify from compilation. The plus icon lets us add an item to the list. Alt-Insert is the keyboard shortcut for adding a file or folder to the list. The minus icon lets us remove an icon from the list. Alt-Delete is the shortcut for this option. The next section is the Java compiler section. This section lets us select the Java compiler to be used, and allows us to configure options related to that compiler. The Use Compiler drop-down menu lets us select the compiler to be used. By default, Intellij IDEA comes bundled with 3 compilers: Java-C, Eclipse, and Groovy Eclipse. Java-C is the default compiler. Eclipse is another compiler that Intellij IDEA comes bundled with. The Groovy Eclipse compiler lets us perform joint compilation of Java and Groovy code. By default, the Use Release option for cross-compilation is enabled. This option allows Intellij IDEA to understand automatically when cross-compilation is needed, and apply the Release Compiler option for Java 9. The Project Bytecode version option lets us select the version of bytecode to be generated. Using the Per Module Bytecode version option allows us to specify the target bytecode versions for individual modules. The plus icon lets us add a module to the list, and the minus icon lets us remove a module from the list. The other options towards the bottom allow us to configure options specific to whatever compiler we have specified. Next comes the Annotation Processing settings. Annotation processing is a step that happens at compile time, when the code is being compiled, not run. Let's take a step back to make sure we cover the basics first. In Java, an annotation has the syntax @annotation, where the word annotation in this example is the name of whatever annotation you are using. Annotations are a form of metadata, and they have no direct effect on the program. Annotation processing refers to how the compiler scans and processes these annotations when the code is compiled. Annotation processing has to do with annotation profiles. An annotation profile is a set of options used for annotation processing. By default, there is a profile that is used for all code compilation. We can create new profiles and associate modules with them to group several modules together to use a particular type of annotation processing. The plus icon lets us create a new annotation profile. The minus icon lets us delete the selected annotation profile from the list. The arrow icon allows us to associate a module to a profile. F6 is the hotkey for this option. If we want annotation processors to be run during compilation, we can enable them by clicking this checkbox. Options that will then become available to us include obtaining processors from the project class path and storing generated source files relative to the module output directory or module content root. Let's move on to the validation section of the settings window. A validator is a program that is used to check the syntax of our code. Intellij IDEA makes it possible for us to use validators when building our code to check its syntax. The Validate on Build checkbox allows Intellij IDEA to run the validators that we choose when the project is building. The results of the validators will be shown in the Messages window, where you can navigate through any issues that were found. In the Validators section, we can select the validators that we want to be run. The Exclude from Validation section allows us to list files and folders that should not be run through the validator. The plus icon lets us add a file or folder to the list. The minus icon lets us remove a file or folder from the list. The next 4 sections pertain to configuring the settings for specific compilers. We can configure the RMI compiler, Groovy compiler, Android compilers, and Kotlin compiler. Next up is the debugger section. We can click the arrow next to the word debugger to see the different subsections that we will be reviewing. Focus application on breakpoint means that when a breakpoint is hit, the location of the breakpoint is shown in the editor, and bring its frame to the front. The Show Debug window on breakpoint option will activate the debug tool window when a breakpoint is hit. Hide debug window on process termination will hide the debug window automatically when the program terminates. The Scroll execution point to center option will keep the line with the current execution point in the middle of the screen. Next, we can specify how we want breakpoints to be removed from the editor. The options are to click a breakpoint with the left mouse button, and drag to editor or click with the middle mouse button. The checkbox underneath these options lets us display a confirmation dialog before a breakpoint is removed, to make sure we want to remove the breakpoint. Next up are some debug options specific to Java. The transport option lets us select transport for connection to the process. The options we can choose are socket and shared memory, which is only available for Windows. Force Classic VM for JDK 1.3x and earlier lets us launch the process to be debugged with the classic VM. Disable JIT lets us disable the JIT compiler. Show Alternate Source Switcher lets us show a switcher at the top of the editor if there is more than one class with the same fully qualified name in the project. The Kill Debug Process Immediately option will allow you to soft kill the Java process. Then there are some options to configure the built-in server. The port field lets us specify the port on which the built-in web server runs. By default, the port is set to 63342. The Can Accept External Connections checkbox allows the files on the built-in server to be accessed from another computer. By default, this checkbox is not checked, meaning that only connections from the local computer are accepted. The Allow Unsigned Requests option allows requests from outside Intellij IDEA to access the server. The final 2 options allow us to specify if the application logcat messages should be shown in the Run console and Debug consoles respectively. Let's move on to the Data Views settings. This page allows us to manage the way that data is displayed in the debugger. Sort values alphabetically allows us to sort the values in the variables pane of the debug tool window alphabetically. The next option, Enable Auto Expressions in Variables View, lets the debugger automatically evaluate expressions and shows the results in the variables pane of the debug tool window. Then there are some editor options we can configure in this section of the settings window. Show Values Inline lets us view the values of variables right next to where those variables are referenced in the editor. Show Value Tooltip lets us show the value of a variable as a tooltip when we hover over the variable in the editor with our mouse when debugging. The Value Tooltips Delay option lets us specify the delay between when we hover over a variable and when its value is displayed as a tooltip. Show Value Tooltip on Code Selection lets us show the value of an expression when we select a code fragment in the editor. We can expand the Data Views option to reveal 3 other section settings: Java, Java Type Renderers, and Kotlin. Let's click Java to go to that section. In this section of the settings window, we can define the way that data is displayed in the Java debugger. Auto scroll to new local variables lets us automatically scroll to new variables that appear in the scope when we are stepping through the code. The show section has several checkboxes that we can use to specify what elements we want the debugger to display. Our options here are declared type, object ID, synthetic fields, static fields, val fields as local variables, static final fields, and fully qualified names. Show type for strings allows us to show the type for pure strings. Show hex value for primitives lets us display numeric variables in hexadecimal format. Hide null array elements in arrays and collections allows us to omit null array elements from being displayed in the debugger. The auto-populate throwable objects stack trace means that the IDE should automatically display the stack trace for exception objects in the variables view. Enable alternative view for collection classes lets us display collections and maps in a more convenient format. Enable toString object view lets us present classes as a result of the toString method. We can do this for all classes that override the toString method, or for classes from the list that we can add and remove items to in the space below. There are 3 buttons to the side of this list. From top to bottom they are Add Class, Add Pattern, and Remove. Add Class lets us add a class to the list. Add Pattern lets us add a custom filter to the list. And Remove lets us remove an item from the list. Next up is the Java Type Renderer section. A type renderer is used to choose how an object is displayed in the debugger on a class-by-class basis. This means that instead of representing a class by its name in the debugger window, we can instead label the class with a custom name such as an ID or tag, etc. All objects, including primitive types and arrays, are available to use with type renderers. There are 5 icons across the top of this window: Add, Remove, Up, Down, and Copy. Add lets us add a new rendering scheme to the list. Remove allows us to remove the selected item from the list. Up lets us move an item up 1 spot in the list. Down lets us move an item down 1 spot in the list. And Copy lets us create a copy of the selected item. If no rendering scheme is defined, the last 4 icons are grayed out. Only the Add icon is available. To start working with type renderers in this window, click the plus icon. This will create a new type renderer for us to work with. Now you will see several options on the right-hand side of the settings window that we can configure for the type renderer that we have selected in the list. We can change the renderer name by editing the text in the renderer name field. In the Apply Renderer to Objects of field, we can specify the object type that we want to be represented by the renderer. Note that this has to be the fully qualified name, which means that it is the namespace name all the way down to the name of the class for that object. For example, the default value is java.lang.object. Java is the first namespace. Inside of the Java namespace is the lang namespace. Inside of the lang namespace lives the object class. Then we have some options that we can configure when rendering a node. Show type and object ID lets us choose whether or not to display class and ID information with the type. Use default renderer lets us display the node in the default way. The use following expression option lets us add a Java expression that we can use to identify the object. The one point to note here is that if we use large expressions or method calls, it can slow down data rendering in some views. After that come options for expanding a node. This option allows us to configure how an object is displayed in the debugger when nodes are expanded. In other words, how the children nodes are displayed. We can choose to use default renderer, use following expression, or use list of expressions. Use default renderer will display the children of the node in the default way. Use following expression lets us enter an expression that we want to use to identify an object. The use list of expressions option lets us create a list of expressions that we can have automatically calculated and displayed as children of the node. Let's move on to the next section, Kotlin. There is only one item in this section which allows us to either enable or disable the showing of values of the delegated properties. Let's move on to the next section for the debugger settings, stepping. This section allows us to configure the stepping options for the debugger, which helps us to improve the debugging stepping speed and specify what elements we want to be skipped when stepping. Do not step into specific Groovy classes allows us to choose not to step into the org.codehorse.groovy.star and groovy.star classes when debugging. After that, we have several options we can configure for Java. Skip synthetic methods lets us skip stepping into methods generated by the compiler. Skip constructors will allow us to suppress stepping into constructor methods when debugging. The skip class loaders option allows us to choose whether or not to step into class loaders when debugging. Skip simple getters lets us not step into simple getter methods. Just to clarify, a simple getter is a method that just returns the value of a variable. After that, we have the option of choosing what classes that the debugger doesn't step into with the Do Not Step Into Classes option. There is a default list here that we can add to and modify. Evaluate finally blocks on pop frame lets us select whether or not we want to evaluate finally blocks on pop frame or not, or to be notified before they are evaluated. We can also choose to resume on only the current thread. After that is a Kotlin section with the options of not stepping into Kotlin runtime library implementation classes. Let's go to the hot swap section next. Hot swap is a useful feature of Intellij IDEA. It allows us to reload classes that we have made changes to during a debugging session without having to restart the entire application. Enable hot swap agent for Groovy code lets us add a special agent to the debugged process if we are working in Groovy. The build project before reloading classes option allows us to specify that the build process should be performed before Intellij IDEA searches for and reloads changed classes. Enable JVM will hang warning allows us to display a warning if we try to perform a hot swap while a JVM is suspended. Reload classes in background lets us specify whether or not classes should be reloaded in background mode. For reloading classes after compilation, we can choose from three options: always, never, and ask. If we select always, it means that classes will be reloaded automatically. Never means that classes will not be reloaded because hot swap is inactive. Ask means that Intellij IDEA will ask whether or not you want to reload the altered classes. Let's move on to the async stack traces section next. These settings are useful for when you want to debug asynchronous code. Asynchronous code means that two or more pieces of code are running asynchronously or at the same time. By default, asynchronous stack traces are enabled. Most of the common options are built in, so we shouldn't have to do much configuration. However, if we do want to add a capture point or place in our code where the debugger captures stack traces, then we can use the list in this section. There are 9 icons along the right side of the debugger. From top to bottom, they are add, remove, up, down, duplicate, enable selected, disable selected, import, and export. Add allows us to add a new capture point. We can click the plus button and add a new capture point, which will be added to the list. This will make the other icons available for us to use. We can double-click any of the cells in order to specify the following information: capture class name, capture method name, capture key expression, insert class name, insert method name, and insert key expression. In the capture class name field would go the name of the class at the top of the stack trace that you want to capture. Capture method name would be the method at the top of the stack trace that you want to capture. Insert class name is where we enter the name of the class where we want to insert the captured stack trace. Insert method name is where we enter the name of the method where we want to insert the captured stack trace. Insert key expression is where we enter the key expression that will be evaluated, and this value will be matched with the key in the captured stack trace. We can enable or disable the selected capture point using the checkbox next to each list item. The minus icon lets us remove an item from the list. The up icon lets us move the selected item up one line on the list. The down icon lets us move the selected item down one line in the list. The duplicate icon allows us to duplicate the selected list item. The enable selected icon allows us to enable all selected capture points. The disable selected icon allows us to disable all selected capture points. The import icon allows us to import capture point settings from a file. The export icon allows us to export capture point settings to a file. The checkbox at the bottom allows us to capture local variables with the call stack. However, You should note that this can significantly slow down the debugging process. Next up is the remote jar repositories section. There are two main parts to this section: Maven jar repositories and Artifactory, Nexus, or bin tray search URLs. These lists work similar to the other lists that we have used in the settings window. We have the ability to add, edit, or remove items in the list. Next up is the coverage section of the settings window. Show options before applying coverage to the editor allows us to show the code coverage dialog every time you launch a new run configuration with code coverage. Code coverage is a measurement that allows us to see how many times each line of code was executed. Do not apply collected coverage means that the new code coverage results should be discarded. Replace active suites with the new one lets us specify if IntelliJ IDEA should discard any active suites, and use the new one every time you launch a new run configuration with code coverage. The Add to the Active Suites option allows us to specify if the new code coverage suite should be appended to the active suites every time we launch a new run configuration with code coverage. Activate Coverage View will display the coverage tool window when an application or code test is run with coverage. There are two Java coverage options: ignore implicitly declared default constructors, and ignore empty private constructors of utility classes. If we have the ignore implicit constructors option enabled, which it is by default, implicitly declared default constructors will be excluded from code coverage statistics. However, default constructors that are explicitly declared will be included in the code coverage statistics. Let's clarify what exactly is meant by implicit versus explicit declaration of a default constructor. Explicit means that the programmer has manually added a constructor to the class. Implicit means that there wasn't a constructor added manually by the programmer, so the JVM will add one at compile time automatically. Ignore empty private utility classes lets us specify if empty private classes, where all other methods are static, should not have their own constructors included in the coverage statistics. The next section is for configuring the Gradle Android compiler. However, I am going to skip this part of the settings window because in section 12, Master Android Studio, we will cover all things Android. This applies to the Instant Run section too, since Instant Run requires the project to be built with Gradle. On to the last section that we are going to cover in this lecture, the required plugins section. If there are any plugins that are required to make our project function correctly, we can specify them in the list here. The plus icon lets us add an item to the list. The minus icon lets us remove an item from the list. The edit icon lets us edit an item in the list. In the next lecture, we will learn about the languages and frameworks section of the settings window.